In this video, we will examine the concept of clock arithmetic. Clock arithmetic is an easy and familiar way to visualize the concept of mods and remainders. To illustrate this, consider the following example, where we are asked to compute 4 different values, all mod 12. We can visualize these values by first drawing a conventional 12-hour clock. Remember that A mod B is the remainder of the division of A by B, and that all remainders must be greater than or equal to 0, but less than the number that we are dividing or modding by. Since we are modding by 12 in all of our examples, but 12 cannot be a remainder when we are modding by 12, we replace the 12 at the top of our clock with 0 instead. Using 0 as our starting point, to compute 12 mod 12, we move to the right or clockwise 12 times, since 12 is positive. After we move clockwise 12 times, we will end back at 0, which tells us that 12 mod 12 is equal to 0. To compute 3 mod 12, we can do the same thing. Starting at 0, we can move to the right or clockwise 3 times, since 3 is positive. If we do so, we arrive at 3, which tells us that 3 mod 12 is equal to 3. How do we compute the mod for a number that is bigger than the number we're modding by? Just like when counting time on a 12-hour clock, whenever we get to 12, we start over, and we do the same with mod. To compute 17 mod 12, since 17 is positive, we move to the right or clockwise 17 times. Note that when we get all the way back to 0 where we started, we are at 12 mod 12. However, we can continue counting in order to get to 17. 17 is 5 bigger than 12, which tells us that 17 mod 12 will be equal to 5. We can place the numbers that are bigger than the number we're modding by on the clock as well, here represented by the numbers in blue. And we can continue this for any number of multiples of the number that we are modding by. In each of these 3 examples, we were computing a positive number, mod 12. However, we can also compute negative numbers in the mod of your choice. Let's compute -1 mod 12. We mentioned previously that because all of the numbers that we were modding were positive, we moved to the right or counterclockwise in order to count the mod. We can mod negative numbers by moving to the left or counterclockwise instead. So, to compute -1 mod 12, we again start at 0 and move to the left or counterclockwise by 1 space, which is 11. So, -1 mod 12 is equal to 11. In orange, we show the corresponding first 12 negative values, mod 12, along with their corresponding remainders in white. For some additional practice, try the following example on your own. Try to compute the following 4 values, mod 7. To get you started, here is how you can visualize the mod 7 clock, with the values in white representing the actual mod or remainder values. The numbers in blue show how the mod repeats for positive numbers, and the numbers in orange represent how the mod repeats for negative numbers. Using the clock as an example, the solutions to these problems are 6 mod 7 is equal to 6, -2 mod 7 is equal to 5, -4 mod 7 is equal to 3, and 4 mod 7 is equal to 4. We can use the repeating nature of the mod in order to solve word problems as well. For example, consider the following problem. On a 24-hour clock, if the time is currently 11 o'clock, what time will it be 79 hours from now? To solve this problem, we need to set up a mod expression and then simplify that expression to get to a singular answer. All of the previous examples, we always use 0 as our starting point for counting on the clock. However, the time is currently 11 o'clock, which means that we are not starting at 0, we are starting at 11. And we are trying to figure out what time it will be 79 hours from now. So, we can begin our solution with the expression 11 plus 79 mod 24. To simplify this expression, we will take advantage of the properties of the mod operation, which we covered in a previous video. The quantity 11 plus 79 mod 24 can be rewritten as the quantity 11 mod 24 plus 79 mod 24, all mod 24. To simplify further, we will try to break the number 79 apart into a multiple of 24 and a smaller number, which will make the computation easier. Notice that the smallest multiple of 24 that is smaller than 79 is 72. So we can rewrite the quantity above as 11 plus the quantity 72 plus 7 mod 24, all mod 24. Using the properties of the mod again, we can rewrite the above into 11 plus the quantity 72 mod 24 plus 7 mod 24, all mod 24. Since 72 is a multiple of 24, 72 mod 24 must be 0. So the quantity above can be rewritten as 11 plus 0 plus 7, all mod 24. 11 plus 7 is 18, and 18 mod 24 is 18, so our final answer is 18. So on a 24-hour clock, if the time is currently 11 o'clock, 79 hours from now, it will be 18 o'clock. Here is another example to get some additional practice. If today is Friday, what day of the week will it be 123 days from now? To begin, label the days of the week with Sunday starting at 0, incrementing by 1 until we get to Saturday, which we will label with a 6. Since the current day is Friday, instead of starting at 0, we instead start at 5. The expression that we are trying to simplify then is 5 plus 123 mod 7. We are working in mod 7 since there are 7 days in a week. Using the properties of the mod, we can rewrite this expression as the quantity 5 mod 7 plus 123 mod 7, all mod 7. 5 mod 7 is 5, and using any of the methods we have at our disposal, we can find that 123 mod 7 is 4. So the expression above can be rewritten as 5 plus 4 mod 7, which is 9 mod 7, which is 2. The day of the week that is labeled with a 2 is Tuesday. So if the current day is Friday, 123 days later, it will be a Tuesday.